All right, so now we're going to talk about the co-function identities. I'd like for you to put the co-function identities in this box down here. So down here you're going to write co-function identities, and there are 6 of them. Okay, so let's see, there were 6 basic identities, 3 Pythagorean identities. There are 6 co-function identities. Now, when I say co-function, I want you to think about it this way. There's a function, and then there's that same function with the word co in front of it, right? There's sine, and there's cosine. There's tangent, and there's cotangent. There's secant, and there's cosecant, right? That's what I mean by co-functions. So, what is the co-function for sine? Cosine. Well, then you might be asked, well, what is the co-function for cosine? Well, it's not cosine, it's just sine, right? So sine is going along with cosine, and cosine is going along with sine. Tangent is going along with cotangent, and cotangent is going along with tangent. Secant is going along with cosecant, and cosecant is going along with secant, okay? They are co-functions, all right? And the purpose of co-function identities are for you to be able to, in an equation, let's say you're trying to solve an equation, or you're doing a mathematical proof. That's for you people who have a future in lots of math, okay? Then I can turn sine into cosine. So sine of theta is equal to cosine in some special way. I can also turn cosine into sine. I can turn tangent into cotangent, and I can turn cotangent into tangent. Secant can be transformed into cosecant, and cosecant can be transformed into secant. It's very convenient to be able to turn one of them into the other if it helps you move along in the solution of either proving an identity or solving a trigonometric equation of some sort, or just an equation that involves trigonometry, okay, or trigonometric functions. So how is sine related to cosine? It's very simple. You're going to love this one. All 6 of them basically work pretty much the same way. Sine of theta is equal to cosine of pi over 2 minus theta. So whatever angle you're dealing with here, whatever theta is, cosine, that's going to be the same thing as cosine of pi over 2 minus that angle. So for example, what if I said, well, hey, what is sine of pi over 3? Okay? Well, what we could say is that sine of pi over 3 is going to be the exact same thing as cosine of pi over 2 minus pi over 3. Okay? And so let's try and figure out, let's go ahead and calculate what is pi over 2 minus pi over 3. Now, we're not going to use a calculator. We're going to do it algebraically. Pi over 2 minus pi over 3. Well, I need a common denominator here, right? And so probably the best common denominator here is going to be 6, right? So we're going to make this into a 6. So we're going to have over 6. So to turn 2 into 6, I have to multiply by 3, right? So here I got to multiply by 3 over 3. 3 times 2 is 6. 3 times pi is 3 pi. So 3 pi over 6 is the same thing as pi over 2. Minus, now I need this one to become over 6. To turn a 3 into 6, I have to multiply by 2. So I have to do 2 over 2. 2 times pi is 2 pi. 2 times 3 is 6. And so 2 pi over 6 is the same thing as pi over 3, because 2 over 6 reduces to 1/3. Now, we can do 3 pi over 6 minus 2 pi over 6. Okay, so 3 pi over 6 minus 2 pi over 6. Now they have a common denominator over 6. And now I can do 3 pi minus 2 pi. 3 pi minus 2 pi is equal to pi, right? Because 3 minus 2 is 1, right? And therefore, this pi over 2 minus pi over 3 is the same thing as pi over 6. And so now we can say that sine of pi over 3 is the same thing as cosine of pi over 6. Well, if you remember the unit circle, you know this is true. Sine of pi over 3 is square root of 3 over 2, and cosine of pi over 6 is also square root of 3 over 2. Okay? And so This is what I mean by when I say cosine of pi over 2 minus theta. You would have to have the same exact thing here and here, okay? This is called a phase shift. It's called a phase shift, okay? And we're going to talk about it a little bit when we get to the graphs of trigonometric functions in the next set of lessons, okay? All right, now that we've got that, we understand that. I won't have to explain that for all of them. I just had to explain it for the first one. Now I can show you. Cosine of theta is related to sine also. How? Well, cosine of theta is the same thing as sine of pi over 2 minus theta. Exact same thing. Tangent of theta is related to cotangent. Tangent of theta is the same thing as cotangent of pi over 2 minus theta. Cotangent of theta is the same thing as tangent of pi over 2 minus theta. Secant of theta is the same thing as cosecant of pi over 2 minus theta. And cosecant of theta is the same thing as secant of pi over 2 minus theta, okay? And these are your 6 cofunction identities. Anytime you want to turn one trigonometric function into its cofunction, you can just go ahead and change it into its cofunction, but instead of having of theta, change the theta to pi over 2 minus theta, and you have your conversion, okay? That's it for the cofunction identities. Now we're going to move on to the negative angle identities.